Hello, this is PJ and this is a 30-day LeetCode challenge in PHP level difficulty easy. And today we have challenge number 3 or problem number 3, and this is the problem we solved the last time, and this time I have a timer, so I'm gonna start the timer. And now let's pick another problem. And previously I used this shuffle function and I quite liked it, so let's see what we're gonna get today. We have another easy problem, so let's see. Sum of left leaves. So find the sum of all left leaves in a given binary tree. Okay, there are 2 left leaves in the binary tree with values 9 and 15 respectively. Return 24. I spent a little bit of time thinking how this tree is actually created in an object. So each kind of row will probably have left and right branch or leaf. So what we need to do, probably typical with all of these problems, we need to loop through all the elements of that object and then loop through each element of any leaf. So let's bring up console. So let's see if we can actually loop through that object. Let's try to search what is actually a binary tree, because it might be some kind of binary tree is a tree data structure in which each node has at the most 2 children, which are referred to as the left child and the right child. Alright, so each node would have a value, and then in the left or right they would also have another node. Okay, let's see. So we need to start somewhere. So let's start from if root sum. Let's do it as a sum 0, and then if root left is not null, then we're gonna add root val. Okay, let's try something else. So our left, then it's gonna be this, and the sum it's gonna be left value, and if right is not null, then our right it's gonna be root right, but we're not adding it to the sum. And let's not do it, and then what we're gonna do is gonna return sum. It's probably not going to work, but let's at least run the code, see what we're gonna get. Yeah, so wrong answer. Output 9 expected. Okay, but at least we have counted 9, which is good. But I think what we need to do still, because we've only now calculated the first sort of level, so now we need to add another level. We need to call this function. If we want to do it in a sort of simple way, then so now we can do so if you add to the sum, and now if we pass as this right. Yeah, let's try that. Yeah, so that is correct. However, it doesn't give us any other examples, so I would expect that it could be any. Actually, it says in a given binary tree. Yeah, so I guess this is not like we're not looking for like a universal solution. I think this is where I was a little bit confused, because I would be looking for like a universal solution. So let's say we can have more sort of nodes here, but it says in a given. Yeah, I think we've solved it, but it's not like a universal solution. So that's the only caveat here. But it is accepted and we submit it. Okay, so this is actually wrong answer. So I think we need to continue looking into this. At least what we need to do is to add sum of left. Yeah, and now let's try to submit. No, it is still not the right. Okay, so let's see what else we can do with that code. Alright, okay, so expected 0 for the input. So maybe try at least. So if then return sum, otherwise return 0. Okay, so we have another case. Output 6 and expected 4. I'm still not quite sure how this array is sort of constructed in that tree, because we really don't know which one is left, which one is right. So it's not represented as a tree like we have here, although maybe it is how many numbers we have. 1 2 3 4 5. So let's say 1 2 3 4 5 1 2 3 4 5 unexpected 4. Yeah, so I wouldn't know why it is expected 4. It's probably like these are all right and this one is left. So let's take this example and then run the code. Okay, I'm not sure why this would expect 4 if we have a tree like this, unless this tree looks differently. So here we have 3 9 20 null null 15. Okay, so I guess this is null null. Okay, yeah, that makes sense. I'm trying to understand, I'm starting to understand how this tree is structured. So it's 3 9 20 and now null null, which is not visible, and 15 17. So with this one it would be 1 2 3 4 1 2 3 4 5 left leaves. Okay, so this leaves. Okay, so I think we only count the left sort of leave. Okay, so we only count it if it doesn't have anything else. Okay, so this is how this example 1 2 3 4 5, this is how our tree should look like. 1 2 3 4 5, and it looks like we only need to count this is like considered like a left leaf, this is not considered as a leaf, and these are right leaves, and this is the only left leaf. That's why we only need to count this in this example. Basically that means to me if left, oh, basically there is no left. and here we can do probably the same, just to simplify the code a little bit. And let's see if that's gonna work. Yeah, that works. So yeah, it took us quite a bit of time to understand what they ask us to do, but we finally got it, and I think let's try submit it if it's gonna accept our solution. No, because yeah, okay, there is probably more to it. Okay, so with this now, another sort of condition in here is that if there's nothing underneath it. So if we go back to this example, and let's say if we had another sort of leaf here, we wouldn't count it. In this example we would have 0, because we actually don't have any left leaves. Right, so in this example, initially I thought that this would be considered as a left leaf, and this one as well, but it looks like if it has the right sort of leaf here, we're not counting it. So in this example the result should be 4, okay, because we're not counting this, although because technically it's not a leaf because it has something underneath it, so it's like a branch. Okay, so to solve this, what I would basically do is, if no left and no right, so let's take this example for our wrong submission and put it in a test case and run the code. Yeah, and it is accepted, so let's maybe try submit it now. Yeah, and it has been accepted. And what is actually interesting and something that we haven't looked before is fast. This actual code is faster than all of the PHP submissions for this task before, and also it's using less memory, so which is good. But it took us a while to actually solve it, and initially to understand the problem and how this tree is actually constructed. Maybe for somebody that is more familiar with binary trees, but I have never worked before as a programmer with binary trees, so that concept was unknown for me. Maybe that is why. So if you're familiar with it, it probably would be easy for you to do it. But yeah, at least I have learned something, and I hope you have learned something too. It took us quite a while, because nearly 45 minutes, but you know, to understand the problem, but sometimes it is necessary, and we've learned something new. So if you have any comments or suggestions, please let me know in the comment section. Otherwise, thank you very much for watching, and see you tomorrow in the next challenge. Thank you. Bye bye.